this is our last set of notes on exponent rules. We're going to talk about negative and zero powers, and we're going to understand exactly what those do when we're looking at exponents. We've already talked about the properties for when we are doing a product. So if I am multiplying like bases, then I'm going to add my exponents. We've talked about when we are dividing like bases, then we are going to subtract our exponents. And then yesterday we talked about when we have a power to a power, then we are essentially distributing and we're going to multiply. So these are going to be the last two. So we know when we're dividing, just like up here, we're going to subtract, and here you can see that they've written it out, 2 to the 5th, 2 to the 8th. We also previously talked about a number divided by itself is in fact 1. So 1 times 1 times 1 times 1 times 1 is just 1. And in the denominator, we're left with 2 times 2 times 2, or 2 to the 3rd power. So if we follow this same pattern of subtraction and we say 2 to the 5 minus 8, because your numerator is always the first when you subtract and denominator is second, we get a negative 3. Well, we're going to learn that when you have a negative exponent, so if I have a to the negative m, we're going to put that whole term on the bottom, and my exponent becomes a positive. Because if we have a negative exponent, that means that it is less than 1. So we can see here 5 times 5 times 5, 5 times 5 times 5 times 5 times 5. So I have 6 of these. And again, this is just going to become a 1 on the numerator, and I have 5 to the 3rd in the denominator. If I use the shortcut 5 to the 3 minus 6, well, I know that 3 minus 6 is a negative 3, which means this is less than 1, so we're going to put a 1 in the numerator, and we're going to write this whole thing in the denominator, and notice that my exponent became positive. We can do the same thing even if they're letters. A over 8 A's, 2, 3, 4, 5, 6, 7, 8. This is all 1. 1 times 1 times 1. So I have a 1 in my numerator. 1, 2, 3, 4, 5 A's in my denominator. If we do the shortcut, 3 minus 8 is a negative 5. And again, that went in the denominator and the exponent became positive. This last one, 4x's, 10x's, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4. This is a 1 on top because a number divided by itself, or even a letter divided by itself, is only 1. So 1 times 1 times 1 times 1 is 1. Over 1, 2, 3, 4, 5, 6, x to the 6th. If I say x to the 4 minus 10, I get x to the negative 6. Again, in the denominator, exponent became positive. So our power, our negative power property says that if we have a power in the denominator, we can write it as a negative and vice versa. Our second power that we're going to talk about is the zero power. So if I have 2 to the 4th over 2 to the 4th, again, 4 2's over 4 2's, all of these cancel. This is a 1, this is a 1, this is a 1, this is a 1. 1 times 1 times 1 times 1 is just 1. Anything to the zero power is, in fact, going to equal only 1 because they all reduce down to 1. So I'm not going to write all of those. You can say 6 minus 6 is 0, which means that this whole expression is equal to just 1. 3 minus 3 is 0, just 1. Anything to the zero power is in fact 1, always. And when you do the negative and zero exponent notes, there is a table showing you exactly why that happens. So you're going to do these video notes second if you haven't already done them. So we can use these properties. I would like you to try these. So you can pause me, and then when you're done, come back. So if we're going to evaluate these, this is a negative. It goes on the bottom. The exponent becomes positive. Here we're dividing, so we're going to subtract 2 minus, be careful, a negative 2. A double negative becomes a positive. This becomes 10 to the 4th. If we have a negative in our denominator, it's going to move to our numerator. 1 over 3 squared times anything to the 0 power is 1. So this is just 1 over 3 squared. And this is to the 0 power. So this is just 1. Okay. Now down here you can see in this example, they've taken our coefficients. They are not like terms or like bases. Remember, we're just going to do normal math with those. No exponent rules. 5 times 3. X to the negative 2. Then it wrote x to the 4th. They wrote our y to the 1. Our y to the negative 4 because this one is in the denominator. So it technically is negative. And z to the 0. And then look, we put them together like we did the very first day. We're multiplying, so we're adding all of that. This became a 1. They've simplified here. This is a negative. It goes in the denominator. So we're going to look at a couple of examples with that today. So again, coefficients, 2 times 5, a to the 2. There's 1s on these, so plus 1. B to the negative 3 plus 1, 10, a to the 3rd. Now this is a negative 2, so that's going to go in the denominator. So these have positive exponents. They stay in the numerator. My negative exponent goes in the denominator. Same thing here. 10 over 5. Those are just regular numbers. We're dividing, so we're going to subtract. So x to the 2 minus the negative 3, y to the negative 4 minus the negative 1. And then again, double negatives become a positive. 2, x to the 5th, y to the negative 3. So again, we got a negative exponent. It needs to go in the denominator. And when we move it to the denominator, the exponent becomes positive. This one looks hard. It's not. We can put 1s here, and we can multiply and distribute our 0. Negative 3 to the 0, x to the 0, y to the 0, anything to the 0 power. This whole thing just equals 1. I would like you to do the video notes on this foldable. Those are posted in Google Classroom. And then for tomorrow, I would like you to try 6 to 18. And if you need to use work in the margin or down here, that's fine. Try to write out those steps like I showed you. And I will see you tomorrow.